So we'll start off on the space news. Change the picture here. This is from NASA. I think it's a generic version of a moon lander and a sender. I don't think that quite matches up with any particular one of the contestants, but it does tie in with the very first news item, which is that NASA has delayed a decision. They normally have they started off with having 3 different groups competing for the human landing system. That is, what's going to bring humans down to the moon as part of the Artemis program. And they had kind of a vote off the island kind of setup where they were going to vote one of these groups off the island. They put that off for a couple of months. It's not really that surprising. I mean, anytime when you get a change of administration, just like in any organization, there's uncertainty about the new management. Nobody's quite sure what the politics will look like. It's not surprising that they introduced a couple months delay. It is a little bit tough, though, that Congress already had cut the HLS funding. That was one of the few things that they did kind of cut out of the budget, even in the previous Congress. So it seems pretty unlikely we're actually going to get people through the NASA space program on the moon in 2024, but it remains to be seen. NASA will adapt. Typically missions change. We go to the moon, we go to the Mars, we develop infrastructure. But NASA does adapt and repackage things. I mean, the current approach of the moon to Mars was sort of a nice hybrid synthesis of the people who wanted the moon or the people who wanted Mars. Hardware programs do get repurposed. We have the Gateway and the SLS all kind of carried over from slightly different missions in earlier programs, and I'm sure something will carry over. So, it's probably not that significant, although it is one thing that will probably interfere with the 2024 human landing. The unmanned portion of Artemis still is going ahead. For instance, Firefly Aerospace got a contract here to deliver a payload to the moon. That's actually the 6th award within their commercial, it's called the CLPS, or Commercial Lunar Payload Services. We've already talked, in fact, in the past about astrobotic and intuitive machines and master space systems all getting contracts, typically to deliver some payload to the moon. And now Firefly also has one of those. And in each of these cases, they generally will have more capacity than NASA is actually paying for. So they're hoping that they can get some other people to buy some space on these missions. So if any of you out there happen to have a need to put something on the moon, there's yet another venue for you here. Mars, of course, the big news is that the really big news is all coming this month after this meeting. You remember 3 different missions to Mars were launched in July. They'll all arrive this month. The 3 missions are from the United Arab Emirates, the HOPE mission. These missions are all quite different from each other. It's interesting. The UAE mission is only an orbiter, so they're mainly going to be looking at the atmosphere, and they're getting there first. They're arriving around February 9th, so very, very soon. China comes next with their Tianwen-1 combination orbiter with a lander and a rover. They will reach orbit on February 10th, but they're not planning on landing. They haven't announced a specific date. What they're really planning on doing is more mapping, and then eventually they'll pick out a really good spot to land, and then they'll land by May. And right now, May is looking like the most likely date for that. And then, of course, there's the US Mars 2020 mission. It consists of a fairly exotic landing system that's been used once before with the skyhook kind of thing, where that's pictured here on the left-hand side of this drawing, where the lander, there is no lander per se, but the sky crane, they call it. It drops down the rover, really, the rockets, slow it down, but then it gets lowered to the surface, and then this skyhook kind of flies off the distance. And actually, the interesting part of this is then after the lander gets there, after the rover gets there, it's going to release the helicopter, the first Mars helicopter. So all that'll happen around the 18th. We're just pretty much going directly there. There's no real significant order piece of this. We just go there. On a slightly closer to home note, the business of launching small satellites is getting bigger and bigger, and Virgin Orbit has finally succeeded. They have a program called Launcher One, and they've launched 10 CubeSats, the very small satellites. They had tried before in May of 2019, and they had failed. This time, they succeeded. And this is a hybrid launch system as shown in the picture here. They take a 747, they fly it up, it takes about an hour for them to get up to altitude and speed. And then they launch the rocket. The rocket itself is a two-stage rocket. And you can see in this picture, they've dropped the rocket. The rocket takes off and continues on to space. They have announced a commercial launch service, but they don't have a schedule yet. So it's not clear where this will go, but at least they've now planted a flag. They're in the business and they've proven they can do it. So they're competing with companies like Rocket Lab. That's the one originally out of New Zealand, now actually out of the US. Astra, Firefly, ABL, and Relativity Space, a lot of these have been venture capital backed and all are reasonably well financed and probably competing for an awful lot of business that everybody hopes will materialize. So it's a small world, but it's getting more and more crowded, partially just because there are so many new entrants and so much more interest in getting these small satellites put up there. There was a record set in the most recent SpaceX launch. It was called Transporter-1, and it put 143 satellites into orbit in just one rocket. That was an all-time record. The previous record was held by India a couple of years ago. Now, the way that a lot of these launches have been going is you have a primary mission, maybe putting up a major communication satellite or a set of them, and then you have these ride shares that just kind of people that tag along, and they kind of shoot off, once they get up wherever the main load is going. This was not quite the same. There were 10 Starlink satellites on there, but almost all the rest of the mission was really just these small ones. And in fact, this is what SpaceX wants to do going forward. They're going to launch these things. In their minds, they're saying every 4 months, but 4 to 6 months, whenever they can fill them up, they'll launch them. And this is the second one of this type. I'm sorry, this is the second one that's gone into polar orbit, and that's been unusual. We covered the time they launched the first polar orbit from Cape Canaveral. Normally in the past, those have been done from Vandenberg Air Force Base. And we'll talk a little bit about why that's significant here. In terms of the business side of this, it's interesting. The business is getting really complicated. SpaceX sells some of these things directly. If you got $1 million, you could put 440 pounds into a sun-synchronous orbit, which I'll talk about later. But if you don't happen to have a load that big, well, then you go to an aggregator. And NanoRacks, as you've heard mentioned earlier today, that's one of those companies, and there's a bunch of other ones as well. They actually end up being the interface that customers have rather than even SpaceX necessarily. Now, what's interesting about this launch is that it's getting to be kind of a threat to all these small rocket competitors. That business is just taking off, literally, people like Rocket Lab and so on. But now, actually, SpaceX is a significant competitor. The way they talk about it is that you can think of, a large rocket like the SpaceX kind is providing bus service. It's pretty cheap, and it'll take a lot of people up to, as long as you want to go where the bus goes, you're in good shape. Now what's happened is companies like Rocket Lab are positioning themselves a little bit differently as a taxi service. They'll be much more custom, maybe faster turnaround. They'll get you up there, fairly quickly, and they'll go exactly where you want them to go because they're serving a much smaller number of customers. This has led to concerns over more and more crowding in the skies. It certainly stressed the U.S. military. They got a list from SpaceX of all of the individual satellites that were being launched, and still they had trouble. Just to identify and start tracking all of those objects coming off there is quite a challenge. And that's of course going to get harder and harder. More on the military here. The whole shift to small satellites changes everything. It used to be that you had a few satellites that were used for satellite reconnaissance, but that made them more vulnerable in satellite warfare cases. Somebody could follow you along in your same orbit, and then blast you out, as has been proven by Russian and Chinese anti-satellite kind of weaponry. And now they're looking very seriously. There's a program called Blackjack to look at using a lot of small satellites. The idea being you're much more vulnerable, kind of the school of fish approach to being in space, as opposed to the one giant creature. And of course, it affects all the people that are planning space warfare of any sort. You can't really take out 1,000 satellites very easily unless you just launch a giant electromagnetic pulse. through a thermonuclear explosion. But the problem with that is if you're an established space player like Russia or China, you don't really want to do that because you're going to take out your own satellites as well. So, it's kind of changing the whole nature of military thinking about space, this immense number of new small satellites. You can see that here. This is the fairing of the nose cone of the Transporter-1 mission. At the bottom here, you can see there's a total of 10 of the Starlink satellites here. That's the internet communications that SpaceX themselves is selling. But then beyond that, those are the big ones relatively. They're there. But then all these small ones are kind of packaged, by all these various aggregators. And we'll talk a little bit more about that. You can see there's little ones here. So typically the aggregators take care of that. And the interesting thing here is that there's a whole new category of spacecraft that are really coming into their own now called space tugs. They've been talked about, there have been various versions of them, but now they're starting to have a significant impact. What they do, an example is the one here on the right, is that they carry a whole group of small satellites, and they're powered, so they can take them to different orbits, so that the ride shares now can be put in with big payloads. They can be managed separately and go into separate orbits from the place that the big satellites are being launched to. Now, this one here is that I'm showing in this picture is from a company called Spaceflight. It's their Sherpa space tug. It carried 13 of the satellites. It launched them over about a 2-hour period. So it took time to get to the orbits that were desired by this particular customer. Incidentally, out of those 143 loads that went up with Transporter-1, there's just everything. I mean, there's communication satellites, experiments of one type or another. One of the satellites that was carried by this space tug contained the cremated remains of 104 people. So people are finding all kinds of use for space, not necessarily productive ones, but the ones that people are willing to pay for. There's another company called D-Orbit. It also had a space tug that carried 20 small satellites. Now, this is, of course, presenting a real challenge to all the small rocket operators that we've talked about, like Rocket Lab, because now they can get the pricing of a bus. You get a much cheaper launch price with the big rockets, but you can still get a custom orbit because these space tugs can take you there. So the business is really getting complicated and getting shaken up. Now, some of the other small satellites here were just launched directly from Transporter-1, and that includes the ones from Exolaunch, Nanoracks, and Maverick. As I was saying before, these people, they contract with these companies as opposed to SpaceX directly. It's going to be a complicated business, but the important thing is it's getting to be big. So we had mentioned that SpaceX was putting people into sun-synchronous orbit for a pretty cheap price. What is that? Well, first of all, it's a polar orbit, or at least very, very close to it. We've shown this picture before where, you have orbits around the equator or orbits that go over the poles, hence the name polar orbit. And those are favored for an awful lot of applications, any kind of weather satellite, spy satellite, or anything in general that's imaging. Say you're trying to track force or something. You like the polar orbits because the Earth is rotating underneath you. So you got the orbit going on here and the Earth is rotating underneath you. And that means that you can see any spot on Earth if you wait long enough, depending on the speed of the orbit and so on. But now there's an additional factor here, and that's this. You can think of this orbit as being kind of stable, kind of fixed in this position while the Earth rotates around underneath it. But now you can also imagine you have another degree of freedom here. The other degree of freedom is the orbit itself, that orbital plane, can rotate around the same north-south axis. So just imagine this orbital plane shown here kind of rotating. And that's when you get into things like sun-synchronous orbits. And that's illustrated by this diagram, actually just borrowed from Wikipedia here, where you got the sun in the center, you got the Earth going around. So you're looking down at the orbital plane. That is the plane that the Earth is in. And you're looking down at the top of the Earth here. So imagine here that the pole of Earth is, ignoring the tilt of the axis, is pretty close to the center here. And you have a polar orbit as shown. There's two different orbits shown here. Now, let's talk about the red one first. This is one where there's no rotation of the orbit. They say the angular velocity of that orbit is 0. So as the Earth goes around the sun, this red orbit here, that stays the same. So that would be the case where it just didn't change at all. But as I said, you have the flexibility. You could rotate it, and the green one is going to be an example actually of a sun-synchronous one, where it rotates going here from the dates here are basically like June 21st to September 23rd and so on. So these are, quarters. In 1 quarter of the year, it rotates. So they show the dots here showing, well, this was what it looked like, back in June, but meanwhile, it's rotated slightly. It's rotated a quarter of the way around to this position and so on. So the idea in a sun-synchronous orbit is that it rotates once per year as the Earth goes around. Now, why did they do that? Well, the reason is that if you look at from the viewpoint of the sun, the illumination is the same. So at any particular, essentially, that satellite, when it passes a particular spot on the Earth, it always sees the same illumination. So it says, for instance, it's the equivalent of being like 2 o'clock. Every time that it takes a picture of a particular spot, it's at the same illumination. And that's really useful if you're trying to track, the growth of forests or, the growth of, somebody's illicit, nuclear activities, whatever it is. It's nice that you're getting the same lighting every time. And so these are really favored for imaging satellites of all kinds. And that's why sun-synchronous orbit is a pretty desirable one, and it's a pretty popular market. So this is something that you can pay, what we say they're charging for this. $1 million to get 440 pounds into a sun-synchronous orbit. So that's what SpaceX and probably others will be selling as well. Okay, we mentioned Starlink in those satellites as part of the transporter mission. It's time to give an update on Starlink as well. Remember, Starlink is the internet service that's going to be offered by SpaceX. As of February 4th, they now have over 1,000 satellites in orbit. They've deorbited some of them, another 60, for one reason or another. They also have acquired 10,000 customers already. These are officially their beta test users. They're in the northern US, Canada, and the UK with 100 megabits download speed, 20 megabits upload speed. 10 of those satellites were put into polar orbit, and that was a first for Starlink. If you remember from previous news, when we've talked about Starlink, here's an example of the orbits that were planned for all these satellites shown in the lower right-hand corner of this. They were never covering the poles in their original plans. The North and South Pole were pretty much uncovered. They apparently have changed their mind. Now they're putting some polar orbits in there. They are going to be able to cover everywhere on Earth. The stated reason, and probably one of the true reasons, is they want to have better coverage in Alaska in particular, and also parts of northern Canada, where they just simply would not have good enough coverage. Looking ahead, we know they're also bidding for military use, and the military would want to guarantee that they could communicate anywhere on Earth, so that this sets them up in a much better position. Now, the second thing they did is they've introduced laser communication links between the satellites. And there's a picture here we've also used in previous presentations, where normally you think of the user down here on Earth, they're going to communicate with a satellite passing by overhead. Now, if you don't have any links between the satellites, that says the only thing you can do is send that signal back to the ground, not that far from the user. So there are going to have to be a lot of ground stations everywhere for Starlink for that to work. But now that they've introduced crosslinks, they always planned to have them, they just didn't get them to work until now. Now that they have them, that says that one user, he can talk, the signal goes up to the satellite, he can go over to another satellite, come down to a user. There might not even be a ground station involved, or if there is a ground station, it could be somewhere else. So when you're over the pole, you don't need to have a ground station anywhere near the pole. This opens up a lot more business possibilities for them. That means, well, polar regions, also the oceans. You don't have a lot of ground stations in the middle of the ocean. And actually a significant factor is hostile countries. They might not officially allow service. Maybe they don't want too much free speech to reach their citizens, or, in a military case, the country could simply be hostile and not want you there. If you have crosslinks, you have the ability to reach all those people, whether or not the governments want you there, or whether there's ground stations anywhere nearby because there's an ocean or a polar, just an ice cap or something. There are some other advantages, though, also. You're also going to be reducing the time delays, or as it's called, latency. Fewer ground station hops. And it's especially important, you don't think about it normally. Everybody just assumes the speed of light is constant, but remember the speed of light in a vacuum is much, much faster than it is in something like optical fiber. In fact, it's only 2/3 as fast in optical fiber. So for internet passing around the ground, it's going from, station to station with repeaters. It's going relatively slowly compared to what you can do in space, which is pretty much a vacuum. As I said, it's only 2/3 as fast on the ground. So there's a lot of advantages in having those crosslinks. And it looks like the SpaceX has finally gotten that right. So right now they only have 10 satellites that have that. They'll have about 60 in that plane. But what they have said is that in 2022 and beyond, basically starting next year, all of their satellites will have the laser links. So over time, as they phase out the old 1,000 satellites, all the new ones will have them. Okay, it's kind of funny. There's a lot of stuff. There's a lot of SpaceX news this time, simply because SpaceX is doing a lot right now. They bought some oil rigs, 2 of them, in fact. These are offshore deepwater oil rigs. So these are the kind that float. That they could be anchored, but they're basically a floating platform. In a way, they're kind of comparable to what they're using right now. They have these big barges that we showed in some of the earlier newscasts. They're floating around, and that's a place for them to land their first stage boosters. And they're looking for more places to land or even take off. And so they're looking to old, used oil rigs to do that now. These 2 that they bought, those were headed to the scrapyard. There was nowhere more need for them. They originally there were 2 different ones. One was 330 million, one was over half, 515 million. That was back in 2008. They're getting them, it's a steal at 3.5 million. So a lot of steel out there, quite literally. And why are they doing it? Well, they're basically making floating spaceports for Starship. This way, the noise, the sonic booms, the congestion, the risk to the crowds hanging around, all of that is removed by having these things out at sea. So SpaceX had long talked about doing this kind of thing, and they're taking the next step. So right now, these two offshore rigs, one's in Galveston and one's down in Brownsville somewhere. They're refitting them, and they're going to be using them going forward. A related topic is space tourism. Still expensive, but it's coming along. SpaceX did announce the first all-civilian space mission coming up. It's using a Falcon 9 and a Crew Dragon. This could be as early as October. Now they've announced things, way ahead of time before with optimistic schedules, but this is getting pretty close and starting to look pretty real. Now these particular ones are this particular one is only going into orbit just within the Crew Dragon itself. 2 to 4 days. It's not going to the space station. And interestingly, it's paid for by one guy. And that guy he's really basically doing, charity work here for St. Jude's Children's Research Hospital. He's paying for it. His name is Jared Isaacman. And he has at least one person who works for St. Jude's and a couple of others, but there is a seat still available. It'll help if you donate to St. Jude's. It's not too late for you to sign up. So if you get, if you happen to have some money sitting around and you want to pay to go up, you can at least enter into the sweepstakes. So what you do, in fact, what I just learned is that the number of tickets you get in effect is proportional to the amount you donate. So if you donate a lot, then you got a better chance of getting up there. Now there are more missions that are being booked. Axiom Space already had booked another one of these civilian missions. This one, they're going to go up and they are going to stay at the International Space Station, and that also will be a first. And the idea here is that they'll spend 8 days aboard the space station. That could be as early as January, so it's getting pretty close. And Space Adventures is another company that is doing the same sort of thing. What does it cost? Well, looks like SpaceX is charging about $50 million per passenger, so it's still not really for all of us. Maybe a few of you out there can do this. I don't know if SpaceX is nickel and diming and also passing through the cost from NASA, but NASA themselves charges $35,000 a night for each passenger and $17,000 an hour for any astronaut time that you happen to need for support. So you'll have to factor that into your costs just in case SpaceX is passing that through. There's other activity unrelated to SpaceX. Blue Origin continues testing. They've flown their New Shepard 4 reusable rocket and their capsule. They just did a test this last month going up to about 66 miles, right at the von Karman boundary, what's recognized as a limit of space. So the New Shepard, this particular rocket is mainly oriented towards suborbital flights where they'll take people up in space for a very short period of time and come back. I don't actually know why they're not just going ahead and doing it. They've tested this thing quite a few times. There must be a few things they haven't felt confident about yet, but they appear to be ready. They've often in the past announced that service would start, in another year, and they've announced that for years now. So I would think they must be getting awfully close. One final update here, and that's that Venus life. This came up as a topic back in September. Some astronomers thought they found phosphine, which is a gas that really wouldn't exist in equilibrium anywhere on Venus. It is too reactive. So they thought this might be a product of life. So maybe there's some life up there, not on the surface where it's too hot, but up in the atmosphere. But doubts have been arising. There's a new study going around. It was actually discussed in the Nature magazine. The preprints are academic, and they're still under discussion. But they're basically saying that there were really just mistakes in the data processing. Phosphine can't 100% be ruled out, but it sure doesn't really look like there's anything there. So if you were thinking that, well, okay, maybe there's some life on Venus, the odds don't look that high right now. It was sort of a very short-term kind of thing. Okay, well, that brings us to the portion of the thing where we ask, how many launches do you think we've had since the last meeting, which was on January 9th? And we normally give everybody a chance here to put in their guesses. And as usual, we point out that suborbital attempts don't count. So for instance, the Starship SN9 serial number 9 test, that one didn't count because it was only a suborbital attempt. It wasn't an attempt to go into orbit or beyond. The crash at the end, which by the way turned out to be a failure of the second engine to reignite near the end, that didn't disqualify him. This picture is showing the last second as the thing is crashing down on the launch pad, but right before the fireball hit, right before it exploded. That's what it looked like. In a classic understatement, one of the lead engineers for SpaceX said, again, we've got to work on that landing a little bit. Yeah, they definitely do. All right, so once again, we have this interesting split of less than 5 or more than 9. And yeah, it turns out, I guess we'll end it right here. Close that off. So it turns out, what is the answer? Well, the answer is, what did I say? 7. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8. There were 8 launches. We've already talked about some of these. Virgin with their CubeSats. The Chinese have done some launches. Electron has done some small satellite launches. Starlink had their own, another batch of 60 satellites. And of course, we talked about Transporter 1. Interestingly, the Chinese space program is getting more and more significant, and there's a lot of players there, including some, I put in quotes, private space firms. There's one called iSpace, where they're trying to be like SpaceX. They're trying to go through and they're pushing toward reusability and fast testing and all that. This particular rocket failed. They had actually gotten to orbit once before. This particular one failed, but they're active. I put private in quotes because most of these are really kind of spin-offs from their major space companies, which are completely owned by the government. But the investment that is behind it is still pretty much from the government. So they're not really completely private in the sense that the US or European ones are. And that ends the formal presentation. Maybe open it up for any discussion or questions before we move on to the main speaker.
I have a question.
Yeah.
Hi, Greg. When would you predict that Houstonians or the city could subscribe to Starlink internet service?
They really haven't been very forthcoming about that. Their coverage is mostly in the north, and they're really only hitting the northernmost states of the U.S. now. But I would think within a year, there's a shot at it. They are bidding and they're getting some federal funding for broadband internet in rural areas of the U.S., which includes states that are not northernmost. That's including down at least as far as say North Carolina. So, but I would think within a year, it's going to be possible.
Thank you.
But they haven't actually really announced a schedule, so I don't think it'd be sooner than a year.
Thanks.
Any other comments, questions?
I have a question for you, Greg. So I saw the number that NASA quotes for their cost. If you take a trip to the space station with them, it's so many dollars per night. So my question is, whose night is it? Because when you're in orbit, you get night every 45 minutes. And that would
Yeah,
be
I
a
think that
quick.
they mean that for 24 hour. I think they're putting that in traditional terms.
Okay.
Yeah, obviously, if it were for every 90 minutes or something, that would be pretty bad.
Yeah. I mean, if they're sneaky, they could do that, I guess, right?
Yeah, that's right. You have to be very careful in defining terms. That's for sure.
Fine print. Okay.
Yeah.
Thanks.
Yeah, maybe you should work for NASA. You could help them make a lot of money, I think.
Greg, I was thinking another advantage to a sun-synchronous orbit is you have continuous power for your satellite.
Yeah, as long as you're in the daylight. That's right. Actually, that's true. And sun synchronous, that concept applies not just to Earth, but it applies to satellites around the moon or Mars. And that has been pointed out that when you want continuous power, that's one way to do it. Okay,